In today's lesson, our topic is about differentiation. So, differentiation is known to be one of the very important lessons in calculus. So, if I have a function, let me call it y. So, my function is called y. So, the derivative of my function y is dy over dx. So dy is the change in y, while dx is the change in x. So dy over dx, which is the derivative of a function, measures the sensitivity to change of the function value with respect to a change in its input value. So usually the function value is y, while the input value is x. So it measures the sensitivity to change of the function value y with respect to the change in x. So let's take a look at this sketch. So I have a graph of the function that is drawn in black, and I have a tangent line which is drawn in red. So the slope of the tangent line, so the slope of the red line is equal to the derivative of the function at the marked point here in red. So what we conclude is that the derivative of any function, so dy over dx, is equal to the slope or the gradient. Now, how can we find the derivatives? So one of the most simple rules in differentiation is the chain rule. So the chain rule states that, so if y equals f of x to the power of n, then the derivative of y, or dy over dx, is n, so the power n goes down, so it's n times the function f of x, then I subtract 1 from the power, so it becomes n minus 1, so f of x to the power of n minus 1 times the derivative of the inside function, which is f prime of x. So dy over dx, again, it's n times f of x to the power of n minus 1 times f prime of x. Now let's go and solve a couple of examples on this chain rule. So in the first example, it says, given that y equals 3x to the power of 4 plus x, all of it to the power of 5, find the derivative of the function using the chain rule. So dy over dx, which is the derivative of the function y, is equal to, so the 5 goes down, so it becomes 5 times 3x to the power of 4 plus x. Then I need to subtract 1 from the power, so it becomes 5 minus 1, which is 4, times. Now I need to find the derivative of the inside function, which is 3x to the power of 4 plus x. So to find the derivative, so I need to find the derivative of 3x to the power of 4 and the derivative of x. So for 3x to the power of 4, the 4 goes down, so it becomes 4 times 3, which is 12, x, and I need to subtract 1 from the power, so 4 minus 1 is 3, plus the derivative of x. Now, the derivative of x, now when I say x, it's the same as x to the power of 1. So the 1 goes down, so it becomes 1x to the power of 1 minus 1, which is 1x to the power of 0, and x to the power of 0 is 1, so 1 times 1 is 1. So always the derivative of x is 1. So dy over dx is 5 times 3x to the power of 4 plus x, all of it to the power of 4, times 12x cubed plus 1. Now in the second example, it says find the gradient of y equals 5x squared plus 1, all of it squared at the point 2, 1. So to find the gradient, I need to find the derivative. So dy over dx is equal to, so the 2, this power 2 goes down, so it becomes 2 times 5 x squared plus 1, and I need to subtract 1 from the power, so 2 minus 1 is 1, times the derivative of the inside function 5x squared plus 1. So the derivative of 5x squared, so the power 2 goes down, so it becomes 10x, and I need to subtract 1 from the power, so 2 minus 1 is 1. So the derivative of 5x squared is 10x, and the derivative of any number is always 0. So it's 10x plus 0 or 10x. So here the derivative of 1 is 0, so that's why the derivative of 5x squared plus 1 is only 10x. Now the gradient at the point 2, 1, so I need to substitute x equals 2 into dy over dx. So it's 2 times 5x squared, so it's 5 times 2 squared, which is 4, plus 1 times 10 times 2, which is equal to 2 times 5 times 4 is 20, and 20 plus 1 is 21, and times 10 times 2 is 20. So I have 2 times 21 times 20. So using the calculator, 21 times 2 times 20 is 21 times 2 times 20 is 840.